Good. Thanks for waiting and welcome again from my side. My name is Mark Eberhardt. I'm the product manager for the Smart Node products Patton, and I'm glad to give you today's presentation for the new portfolio we have on the access side for VDSL technologies. So we are really excited at Patton to give you the opportunity to learn more about our latest product updates. To get started, I want to give you a quick overview on the items I want to go through with you today. First of all, what's new in our portfolio in terms of VDSL. Then I want to say just a few words about the technology. And then I want to go into the use cases, how we see them, how our products can be of a benefit to you for various use cases. And then towards the end, I'm open to have a Q&A session if there still should be some questions from your side. So that's about the agenda of today. If during the presentation you might have some questions to me, just feel free to post them using the questions menu on your screen. So I'm glad to answer those at the end, as I said, and also if we don't have enough time, I'm glad to get back to you through email after the session. Good. So what's new? We have VDSL products in our portfolio now, so that's really the great news now. There is several product variants that carry a VDSL interface terminating the access link coming from your operator, from the carrier, and that starts on the low end with a small tiny box. Which is doing VDSL. It can be used as a simple modem in bridge mode, for instance. I'll come to that in which use cases that might be useful to you, but also it can be used as a router, which comes with all the major functionalities that are needed. Then going further up in terms of complexity and feature richness of the products, there's of course also smart nodes having now VDSL interface to terminate the access links, and that smart nodes are available in different variants. So it can be as a tiny little smart node as the 55 series, with a VDSL interface acting as an ESBC, but also you can use it as a router. And then there is more variants having TDM interfaces. So the TDM interfaces then can vary from whatever E1, T1, PRI, or to FXS, or to BRI. So there is a lot of variety there. So as I put it here, for almost every use case, we have the right product for you. Now switching to the VDSL technology, so how it evolved, why it's being used in the market. I think one of the main drivers here is more bandwidth. So there is more content available in the internet that needs to be downloaded, distributed down to the client. So more bandwidth is needed. For that, VDSL was invented, let's say, where it's possible to carry more data across an access link as it was possible before with ADSL, for instance. However, to do so, to deliver more bandwidth, there is technical difficulties or even problems, let's put it that way. One of the problems here is, as I try to illustrate with the images on the right-hand side, that there is interference in the cable of the signals that are being carried across the cable, having multiple twisted pairs. So which limits the possibility of transmitting data, so the bandwidth is limited. In order to overcome that problem, the vectoring technology was introduced, and how that works in a simple way, you can see on the bottom right side illustrated that those noise signals are being measured for each pair, and on the other hand, there is an anti-noise being introduced to the line to bring the signal to a zero level, let's say, so which means that there is more bandwidth possible on that certain line. Of course, on the Patton products, we support this technology, so the G-vectoring technology, this is called. But among that, there is other functionalities that are built in into the new VDSL products we have in our portfolio now. On the top row here of that table, you can see there is different VDSL profiles available. So with, of course, different characteristics there, with different speeds and supporting different length of cable. So we support a big variety there. So it's from profile 8A, supporting up to profile 30A, you can get on the Patton product. So that's standard built in. It's all enabled, so there is auto sensing on the products, choosing the right profile, which is given or configured from the line concentrator, from the DSLAM, so-called. Different modes we support, ATM or PTM mode. So ATM was being used on ADSL, but it's also possible to be used on VDSL links. So again, there it depends on how the DSLAM is configured. Of course, both modes are supported on the Patton products, and there is even a really nice feature. One of the features I really like, the auto sensing between VDSL and ADSL. So it requires less complexity in the configuration of the products. So they detect automatically which line is connected to the device, if it's a VDSL line or an ADSL line. Now, so much about the technologies. I want to go into the use cases a little bit and illustrate how and where our products are to be used for. So starting from the big picture on the right-hand side, we have the service provider that usually has fiber that is laid in the ground, which connects to cabinets that you would usually find along the highway, let's say, or along the streets, going to residential areas or to business districts. From there, because of cost matters, usually for the last mile, the copper is still present, is still there, and that's really where VDSL and ADSL comes into play. So where with the existing copper line, that's usually which is pretty old, many years, still a high bandwidth can be delivered through that last mile copper wire using state-of-the-art technology such as VDSL. Now, if we are putting products there for this application, so on the cabinet side, where the fiber signals are being converted into a electric signal again, such as VDSL, as I said, a so-called DSLAM is being used. So that can be a forefront 3210, for instance, from Patton. And then on the customer premise side, whether it's residential or a business, it can be a smart node IAD that's terminating the VDSL signals and is delivering TDM telephony signals such as BRI or T1 PRI to the customer premise-based PBX. Or, of course, we can do connect to an IP PBX that's on premise at the client side. So as you can see here, pretty clean installation with just a single device terminating the access link and acting as an ESBC, delivering the necessary features from service level agreements, monitoring up to normalization, security aspects, and so on. So now let's focus a little bit more on the customer premise side, on how the installation is being done there. How different architectures look like, where I would like to elaborate a little bit more. So what we came up with is a layout of different possibilities on how you might want to supply your client with services, and then of course how these services are being delivered with what kind of equipment. So there's different ways to do so. Four different main architectures we see. For now, I would like to focus on the two-box architecture. As you can see on the right-hand side, two-box, which is being done with a simple modem terminating the access link, so VDSL in this case, and then the second box being used as a router gateway appliance. So how this may look like if we are placing Patton products for that architecture. You may want to use the OS2201 for that. That's really a great device, very cost effective and very feature rich, which is terminating the access link. And then on the right-hand side, there is a smart node connected to that. The smart node being responsible for IP routing, for internet security, doing NAT and NAPT, as well as stateful firewall, which is built into that unit. And of course, it's doing voice over IP. So there, phones can be directly connected to the smart node or also a premise-based PBX. The local LAN, whether this is PC or even a TV, as illustrated here. So with that kind of setup, we see a clear benefit in going into the future where access technology is changing. So they're replacing the OS2201 with a newer version, carrying the latest access technology is cheaper than replacing, as I will show you later on, an IAD that's having all the interfaces built in. Also, this sort of application or architecture, I should say, is more flexible for adaptations as far as they're required. For instance, if there's a new service being deployed to the client, so there you could add additional units that might be required to deliver that service. However, let's say the downside in that case here is it's more complex to be set up, as there is two devices that are required to be configured or to be provisioned. And also from a logistics point of view, depending on how you're set up, from a stocking and ordering process point of view, it might be more complicated or even more costly, as there is two items you need to take care of with ordering and stocking. Now, another example I would like to pick out here in terms of architectures on how devices are being installed at the customer premise is the IAD, so the fully integrated access device. As you can see, it's terminating the WAN link, it's acting as a modem for layer 1 and 2. It has built-in IP routing functionalities for the layer 3, but also the services are being handled and terminated on that unit, which is being done on layers 4 up to 7. So the IAD installation, as you can imagine, will look simpler in a way that there is just one device being put on the customer premise instead of the two, as we saw before. So in that way, it might be a simpler and cleaner installation. So there's less boxes and cables, so it's less complex to set up from a hardware perspective. Also from a management's point of view, monitoring the device and the services the device is delivering to the client. It's simpler, as there is just one sort of API you would need to get access to, in contrast to the other architecture I showed you before, where there is two devices. So with that, it's less boxes, and from a logistics point of view, it's cheaper in that sense. In having just one stocking unit, you need to send out to the client. To give you just an example of the SKU for that unit I'm showing here. So that's one with 2 BRI and 4 FXS ports, and the appendix here, AVB, that's called for Annex B ADSL and VDSL support. So that unit is carrying the new interface for VDSL with the auto sensing back to ADSL, whatever this is needed, depending on the infrastructure you'll find at the customer premise. So as a conclusion here, in terms of one box versus IAD solution, IAD two box solution, it really depends on how your company or your client is set up, how the processes are set up. So really the deciding factors I identify here are from logistics, ordering perspective, in terms of the deployment, how complex you can handle deployments down to the customer, service flexibility. So these are all things that play into a decision if you as a service provider or you as a value-added reseller would like to deliver services to your clients. So in one case it might be the IAD, in the other case it might be a two-box solution that's more beneficial to you or more easier to handle for you, where the total cost of ownership is at the end lower compared to the other architectural approach. Staying with the Patton products here, so for the Patton IAD, the integrated access device where everything is in one unit. So those units do 4 major functions, as you can see here. So on the DSL part, as I've illustrated before already a little bit, so there is a lot of technologies being supported. Regular VDSL, VDSL2, including the G-vectoring support, but also on the ADSL side, we support all the different flavors of ADSL there. Different annexes, as you can see. So even the Annex J, which is quite popular in Europe, as we see, which is giving you a higher bandwidth compared to the older annexes, as we know, such as Annex B or Annex A. There is a gateway functionality built into the IADs, of course, as you know, so that can vary from 2 up to 8 BRI ports, which can be software controlled to be either an NT or TE port. There is analog interfaces. There is a combination of both, actually, and also PRI interfaces, so PRI for E1 or T1. The IADs come with ESBC functionality built in. So for the ESBC part, this is being used for service demarcation between the LAN and the WAN side of the VoIP communication. There is QoS functionalities built in. Optionally, you can enable PacketSmart, which is a voice monitoring and network assessment tool, but also in terms of security, the ESBC function, which is part of the IAD, is very valuable to your clients to protect the LAN side communication equipment from any potential fraud strikes coming out of the unsecure public internet. And last but not least, in terms of survivability, there is different options actually to fail over to alternative links, for instance, in case the DSL, the VDSL link breaks down, the unit is capable to do a failover to a alternative WAN link, such as another wired connection to be connected through Ethernet, or it can be done through a 4G cellular modem support, where we have a USB interface where you might want to connect a USB dongle to it. Switching to the two-box solution again, so there's the OS2201, this nice little box. On the VDSL part, on the VDSL side, it's supporting the same feature as the Smart IAD. So the different access technologies with the different profiles is coming with it. And then, of course, it can do IP routing, including network address translation, including port translation, static dynamic routing, DNS relay, just to pick out a few of the main features there. And it's also supporting VPN. So it's a really small and nice, cost-effective box, the OS2201. Well, so much about the products. Really to highlight it again here, the benefits you're getting from having Patton products in your portfolio. As most of you know, it's really high quality product, stable, reliable. So in order to achieve, in order to hold that, actually, I must say, there is continuous software updates you can get every 2 months free of charge, which are constantly being improved, as usually the environment our devices are being used in is not stable, so it's dynamic, it's changing. There is new standards coming up, so really we adopt to all these changes to eventually really bring a stable product and keep it stable for the clients using it. Interoperability, so we have a proven interoperability, so there is many brands of PBXs, whether this is IP PBXs or legacy TDM PBXs that work with Patton products, soft switches. So there is really a lot, and there's a long list you can find on our webpage. For administration of the smart node units, there is one operating system which is using the same configuration scheme there. So it also makes it simple and easy for your technicians doing the installs, that they just have to learn once how a smart node is working, and then it would apply for all the different variants of smart nodes. Our products are flexible, so they can adapt to almost every use case. So a lot of things can be configured so that the device is working the way it has to, delivering high quality services to your clients. Security, an important aspect. So we support state-of-the-art ZTLS and SRTP for the voice communication part, and for on the data side, we support OpenVPN, but also IPsec for a secured virtual private network. All IP, so from legacy to all IP, of course, we support the all IP part with our ESBC functionality, as I've mentioned already before a little bit. More about our products you will find on the Patton webpage. Just go out there and reach patton.com. Also recently uploaded, we have the Smart Integrated Access Solution Guide. So that's just new. Have a look at it, get a free copy from our website. Good, so that's so much about the VDSL solution. I want to quickly switch to the questions. So there are a few here. So there is one question: what annexes are supported? So for the annexes, that's on the ADSL side. So we support A, B, L, M, and J annex. Then there is another question if L2TP is supported. So L2TP is supported on the small little box, the OS2201. However, on the smart nodes, it's going to be there in a few months. So we're actually integrating L2TP as well. So in a few months, you'll also see L2TP support. Then another question for the OS2201, if BGP is supported on that device. So for BGP, you would have to go to the smart node devices. That's supported there. However, the OS2201 is not supporting that, as we don't see the demand for BGP on this kind of segment. Then let me see, what else do we have? Compatibility with DSLAMs. So I'm glad to share the compatibility lists there through email with you, Najib. So I'm glad to do that. So there's a long list actually. So I don't think it makes sense to go through all the certified DSLAMs there. Another question I see for auto sensing of ADSL, VDSL, is it also detecting the VCI and VPI? So that parameters, they would have to be pre-configured initially. So that's up to the deployer, let's say, doing the installs. You'd have to come up with the settings for ADSL and VDSL, but then really once it's being deployed, it will detect if it's VDSL that should be used or if it's ADSL. Okay, good. That's so much about that. There is another question here. If we support three-way conferencing, so that goes down to the smart nodes. Three-way conferencing, that's supported. So you'll find more details on that, in which way this is supported in the user manuals. And I think that's about it from what I can see. And also I see time is up already, so time goes fast. Should you have any more questions, so feel free to contact us. So you know how you can find us. So just find the email address and phone number information on our webpage. So I'd be glad to receive your inquiry. Okay, that's so much for today about the VDSL portfolio. Thank you for your attention. Thanks for joining, and stay tuned for any upcoming webinar we'll do next. So I'll be glad to see you again sometime soon. Thanks again for your time. Wish you a nice rest of the day. Thank you.